All right, today's lesson, I'm kind of covering two lessons, 4.5 and 4.6, solving quadratics by taking square roots will be one of the lessons, and then factoring will be the other lesson. So let's do a few examples of each of those things. So we talked a lot about quadratic equations, their graphs, factoring, their forms, but we haven't solved any equations with quadratics. All right, so to solve means to find the zeros or where your parabola crosses the x-axis, which that would also be called your x-intercepts. All right, so you'll see all these different kinds of things when you're asked a problem about quadratics. They might say just to solve the equation. They might tell you to find the zeros. They might tell you to find the x-intercepts. And all of that will be doing the same type of math. It's just called different things, okay? So with our first one, we are going to look at examples where we are just solving by taking square roots. All right, so my first example, I've got 4x squared plus 10 equals 46. All right, we'd solve it probably like you'd think. I've got my variable x squared. I need to get my variable alone. So I'll go ahead and subtract 10. I'll divide everything by 4. All right, then I get down to x squared. It's not just x, right? So I need to undo the squared. So I will take the square roots of both sides. But what I need to remember is there are two things that will make that true. All right, so 3 is an answer, but there's a second answer. All right, there's also negative 3. Because if you remember, if I take 3 and square it, I will get 9. And if I take negative 3 and square it, I will get 9, because negative 3 times negative 3 is also positive 9. So I need to make sure I remember both answers. A lot of times when we're writing these by hand, your short mathematician way is to write as plus or minus 3. So you'll see a plus or minus show up every now and then. In Math Excel, it's going to want you to write both answers with a comma in between. So it's going to do this instead of, I don't know if it has that symbol for you to include or not. So we'll just put them separately. Okay? Let's look at another one. So I've got 3x squared minus 5 equals 25. So same thing as before, I need to get my x squared all by itself. So I'll add 5. So 3x squared equals 30. Divide both sides by 3. So x squared would equal 10. Undo the squared, take the square root of both sides. All right, if you take the square root of 10, your calculator is not going to give you a nice whole number or integer like we just had before. You're going to get a messy decimal. All right, we don't want to write down the messy decimal. So I'm going to write down, well, the square root of 10 is one of my answers, but also negative square root of 10 would be one of my answers. So you'll put it in that exact radical form. Okay? So if you're getting a problem wrong like that in Math Excel, it might be because you typed in the decimals. You want that exact form. Square root of 10 is the exact number. If you take the square root of 10, it's a big, long, messy decimal that lasts forever. We'd have to round it to write that answer. Okay? All right, here's our last example for taking square roots. So I've got 4x squared minus 25 equals 0. So sometimes we'll see problems like this. So if we had problems where we had to graph something like y equals 4x squared minus 25, and then they'd say find the zeros or solve that equation or find the x-intercepts, then you'd be replacing your y with 0. All right, so you'll see problems in that form, and then it's going to look like what I have here as 4x squared minus 25 equals 0. All right, but still need to get my x squared by itself, so I've got 4x squared equals 25. Divide both sides by 4. Now, 4 doesn't divide into 25 evenly, so I'm going to go ahead and leave it in this form for right now or as a fraction, because if I go ahead and take the square root of both sides, I can take the square root of 25 and get something nice. Right, I'd get 5. And I can take the square root of 4 and get something nice. That would give me 2. But don't forget there are two answers, both positive and negative, 5 over 2. All right, so that's kind of the different ways you'll see it. You might have a fraction answer, both positive and negative. You might have a square root answer, both positive and negative, or just a nice plain integer, both positive and negative. All right, so let's take in square roots. We are going to look at 3 examples for solving by factoring. All right, so my first example, 2x squared plus 4x equals 6. So you might look at this and go, well, that wasn't that hard solving with square roots. I've got an x squared here. I'd like to solve with square roots. All right, I can't solve with square roots here because I have an x and an x squared. In the last 3 problems, I only had x squared. I only had x squared. Right? In every single problem, that's all I had. So I can only use square roots if I only have an x squared. If I have another x or another variable there, I cannot use that method. That method's nice and quick, short and sweet. All right, but I can't do that here. So I can't get a variable by itself because I have 2 variables. I can't put those variables together because they are not like terms. They've got different exponents. So my only way I can do this is to use factoring. All right, in order to solve by factoring, I must get the equation equal to 0. All right, so I need to get everything on one side. So it kind of goes against everything you've done when you solve equations. You typically get the variable by itself. In this case, I need to subtract 6 to the other side so that this equation would be equal to 0. So 2x squared plus 4x minus 6 equals 0. Right? So basically it's in standard form. Right? Your A, your B, and your C, when we think back to quadratics in standard form, equal to 0 shows me where I'm going to cross the x-axis. All right, when talking about graphing. All right, so we are going to factor this. We'll use the same methods for factoring. I'll still look for a greatest common factor, which would be 2. So I will factor that out first. Divide everything by 2. Good news is if you forget to factor out a greatest common factor, it will not affect your answer. All right, it simplifies what you're solving. It will affect things that we simplify next quarter. So I will always suggest to still factor out your greatest common factor because it will cause problems later. Okay. All right, so then I'll continue to factor this. So I've got x and x. I need to multiply to -3, but add to a +2. So that means 1 positive and 1 negative. My 3 will need to be positive. My 1 would have to be negative for that to work out. All right, so the reason why factoring is good is factoring is in a multiplied form, right? I'm multiplying these things together to equal 0. So if you think about, well, How are you ever going to get 0 when you multiply something together? What do you have to multiply it by to be able to get 0 as the answer? You have to get one of these things to be 0. All right, so that means I'm going to take this factor, so I'm multiplying by this. I want to figure out, well, what would that be? What value of x would make that 0? Well, -3 would make that 0. All right, so if you think about, well, would that make sense? So if I take -3 plus 3 times -3 minus 1, right? I just replace the x values with this. That would be 2 times 0. Doesn't matter what it is. If it's 0, it's going to make everything else equal 0. So that would make it true. Okay, so I want to take the other factor I'm multiplying by, x minus 1, and I want to figure out what value of x would make that 0. Well, that would be 1. Why would that make sense? Well, if I take 1 plus 3, I get 4. That doesn't matter. But 1 minus 1 would make that 0. So 2 times 4 doesn't matter. I'm still multiplying it by 0. So I satisfy the equation to equal 0. So here are my two solutions. All right, so when I have it written in that factored form, I find each separate factor, set them equal to 0, and then I've got my two solutions. All right, we'll go ahead and head to lunch. All right, so for our next example, they might be able to hear you. All right, number 2. So 3x squared plus 5x equals 2. All right, so same thing as what we did last time. I cannot get an x by itself, or I can't get x squared by itself. Well, if I did, I'd have an x on the other side, so it does not help me to solve. So I must use factoring, and I must get it equal to 0. So I'll need to subtract the 2 to the other side so that I can factor this and then set each factor equal to 0. So in our last problem, we could factor out the greatest common factor of 2. We have a 3 here in front of our x squared, but 3 does not go into 5 or 2. So bummer, I cannot pull out the greatest common factor, but I can still factor it. So I've got then 3x times x to multiply to that 3x squared. I still must multiply to -2. So my options would be 1 and -2 or -1 and +2. And it will matter where I put them, and it will matter where the sign goes. But we can kind of just try something out. So if I try this one first, let's test it. Let's see if that works. If not, we'll try something else. All right, so then I've got my 3x squared. 3x times -2 is -6x plus 1x, and then -2. So right now, this just added to -5x, and I need a +5x, but everything else is good. I've got the 3x squared, I've got the -2, and I've got the number that I want, just the wrong sign. So that means I just need to flip my signs around. So I don't want this. So I'm just going to rewrite it so I remember what I had the first time. So that means I need 3x minus 1 times x plus 2. So I keep everything in the same order, the same place, but I switch the signs in the middle, and now I will add up and combine to 5x. Okay, so each factor here, so the factors are the ones set in parentheses. So 3x minus 1 is multiplying x plus 2, so I need each separate factor equal to 0, that x plus 2 equal to 0. There are two values of x that would make this true, because there are two values of x that you could get one of the factors to be 0. All right, so from here I'm going to add 1. and then I'll go ahead and divide by 3. So x would be 1/3. And here, just take away 2, right? So x equals -2. So in Math Excel, you put your two answers, you put a comma in between them. If you do get a fraction answer like 1/3, you should write it as a fraction. Don't put 0.33 because that's going to be rounding it. It's not the exact answer. So write as a fraction if you get a fraction, or you're just your number. All right, we'll look at one last example. So I've got 16x squared equals 8x. All right, now I want to solve this equation for x. I can get my x squared or my x by itself technically, but then I'm still going to have an x on the other side, so I'm running into the same issues as the last two examples. So I need to get everything on one side equal to 0, so subtract the 8x to the other side so that it equals 0, and then factor. All right, so I should always look for greatest common factors. So this time I do have one, would be 8, but also an x. All right, each term has an x. So then I'd be left with 2x minus 1. All right, this is the first time we haven't had two sets of parentheses. But when I go to solve, I will still set this 2x minus 1 equal to 0, and I will also set my 8x equal to 0. All right, because this is multiplying that. So if x is 0, well, 8 times 0 is 0, and then 0 times what's in my parentheses would still make it 0. So everywhere I have one of my variables being multiplied, I have to set that equal to 0. This one I'll go ahead and add 1, divide by 2, so then I'll get 1/2. So my two solutions would be 0 and 1/2. Just remember, like whenever you solve equations, you can always plug those back in and double check that you are correct. I know in Math Excel, it's going to say, excellent, great job, or whatever, and tell you that you're correct. When you're doing your quiz or your test, you will not get that feedback. So make sure you still are, testing, plugging 0 in, right? 0 squared is 0, times 16 is 0. That would equal 8 times 0. Make sure that that still makes sense and you can plug that back in when you have extra time on a test or a quiz. All right, that is our lesson for today. Enjoy your homework.